Good day everyone, this is Delas of ME3A and we're gonna solve a problem about flexural stress. But before we delve into our problem, let's have a quick recap first on this topic. So flexural stresses by elastic curve. We have discussed that stresses caused by bending moment are known as flexural stress or bending stresses. The figures here shows the pure bending of a solid member. Figure A shows the behavior of member caused by pure bending. Side AB is subjected to tension while AB is for comprehension. It is a representation in longitudinal vertical section, while figure B is the representation in longitudinal horizontal section. The maximum flexural stress is the stress at the radius or maximum distance of surface from center of the member. It is equal to mc over I, and the normal flexural stress is at any distance from center of the member, which is equal to negative my over I, where m is the moment, y is any distance from the center of the member, c is the radius of the member or circular bar, and I is the moment of inertia. So here is the list of moment of inertia for objects with the same material density. So much for that, let's get into our problem, which is the number 9.11. A. Determine the location and magnitude of the maximum absolute deflection in AB between A and the center of the beam. B. Assuming that beam AB is W460 by 113, m sub 0 is equal to 240 kilonewton and E is equal to 200 GPa, determine the maximum allowable length L of the beam if the maximum deflection is not to exceed 1.2 millimeters. So let us show first the free body diagram of the entire beam AB. Then let us take counterclockwise as positive. Now taking moment about B, so summation of moment along B is equal to 0. Then, negative 2m sub 0 minus RAL is equal to 0. So, RA is equal to negative 2m0 over L. Next is to derive bending moment. So, summation of moment along M is equal to 0. Then, negative m sub 0 plus 2m0 over Lx plus m is equal to 0. So, m is equal to m0 over L times L minus 2x. Next thing we gotta do is find the differential equation of the elastic curve. So we use equation d squared y over dx squared is equal to mx over ei, and write ei d squared y over dx squared is equal to m0 over L multiplied by L minus 2x. After differentiation, we then arrive ei equal to m0 over L multiplied by Lx minus x squared plus c sub 1, which is our first equation. And Ely is equal to m0 over L Lx cubed over 2 minus x cubed over 3 plus c sub 1x plus c sub 2 is our second equation. So by letting x is equal to 0 and y is equal to 0 from equation 2, we find c2 equal to 0. And as x is equal to L and y is equal to 0, again using equation 2, we can find C1 is equal to negative m0L over 6. So the equation of the elastic curve, we have y is equal to m sub 0 over EIL multiplied by L squared x over 2 minus x cubed over 3 minus L squared x over 6. This is our third equation. By differentiation, we have dy over dx, which is equal to m sub 0 over EIL multiplied by Lx minus x squared minus L squared over 6, which will be our fourth equation. Since in A, we are asked for the location and magnitude of the maximum deflection in AB between A and center of the beam, so we set dy over dx equal to 0 in equation 4. So by solving for the maximum value of x, or the x sub m, we get 0.21132 L. Then from equation 3, we can get the maximum value of y, or y sub m, which is negative 0.016037 m sub 0 L squared over EI. So for B, we are going to find the maximum allowable length L. Now for designation W460 by 113, we have our moment of inertia, which is equal to 554 times 10 to the power of 6 millimeters to the fourth. Since Y max is equal to 1.2 millimeters, and we already got the Y max equation, so we can now derive our equation for L. So L is equal to EI multiplied by Y max over 0.01600375 m sub 0 raised to 1 half. We have E is equal to 200 times 10 to the power of 9 Pascal. I is equal to 556 times 10 to the power of 6 millimeters raised to 4, which is equal to 556 times 10 to the power of negative 6 meter to the fourth. And our Y max is equal to 1.2 millimeters equal to 1.2 times 10 to the power of negative 3 meters. And M sub 0 is equal to 224 times 10 to the power of 3 Newton meters. So by substituting the given data, we get L is equal to 6.09 meters. So that's it for our problem. I hope you learned something and thank you for watching.